Alrighty, CNT125. We are working on Chapter 8 on segmentation. This chapter we have a lot of big concepts. Purpose and segmentation, subnetting, and then applying subnets or subnetting, VLANs, configuring VLANs, applying VLANs, and then segmentation options that are available in the cloud, using some of these pieces for our cloud computing. So before we dig into anything new Chapter 8, we need to remember some basics from Chapter 3. So let's do a quick review of some basics from Chapter 3 that'll really help us out. First thing is, I need to remember at the network layer, my IP address is my main address that I'm dealing with, whether it be IP4 or IP6, that's the main address I'm dealing with. Layer 3, used for routing purposes, routers read and interpret and route based on these addresses. We also call them logical, software, layer 3, network layer address, any and above, any of those names for our IP address. We do have IP version 4, IP version 6. IP version 4 is a 32-bit written as 4 decimal numbers, like so. And our IP6 is 128 bits written as 8 blocks of hex numbers, 32 hex numbers. An example like so. We also need to remember that we have, along with the logical, our physical address, and remember the purpose of these. Our logical address we already mentioned was IP, network layer address. Don't forget the physical address, MAC address, data link layer address, hardware physical address. Well, if we remember the function of each of these, a lot of this addressing is a little easier. My logical address is used to get a chunk of data or a piece of data through a network and through the internet, if you will, or through networks to the correct network. My example I always use is a certain campus of hack. So it's coming through the internet and needs to get to the York campus of hack as opposed to the Gettysburg campus of hack. Once that chunk of data gets to that router and gets it to the York campus, the router and IP address, if you will, is kind of like, I'm done. Something like a switch is going to get you to the correct node. And then we move on to the MAC address. Our switches read MAC addresses, maintain a table of MAC addresses, and this MAC address is on this port, this MAC address on this port, this MAC address on this port. So when that frame of data, if you will, comes into the switch, it goes, ooh, it's going to this MAC address. I know that it's on port 7, and it sends it out port 7 to only that computer. So the MAC address, once that chunk of data gets to the correct network, in this case York as opposed to Gettysburg, the switch picks it up and reads, okay, oh, this MAC address on this port, and it gets it to that device, that computer, that phone, that printer, if you will. So the correct device at that network. So again, router is using the IP address to get to this campus as opposed to this one. Once it gets into this campus, the switch is going to read it and get to this device as opposed to the many other devices in that network. Keep that in mind. Keep that in mind as we're talking about all of this stuff. Going back to IP addressing, remember we can set them statically. Excuse me. This is assigned by the network administrator. We're going to do that a lot this semester in our labs. We're going to set it to what we want it. To do this, you literally go to the client and set the IP subnet mask gateway address for that device. That usually gets used for static devices like printers and servers kind of thing. Most of the devices are going to get a dynamic address, but static address we can set to what we want. So on our IP settings, we don't do obtain IP address automatically. We say use this IP address. That's our static IP address setting, and we need to plug all of those numbers in correctly. So typically this is only done on those static things or by devices that the network admin wants to have a specific IP. I always joke that, Joe Schmo user, think about a lot of the people they would probably not get all these numbers right. And if one or two of these numbers are off, it's definitely not going to have communication on the network. I can also set it dynamically. Here, when I say dynamically, it goes out and asks the network, hey, DHCP server, can you give me an address to use for connectivity? And the server, DHCP server, whether it's built into a router or a separate server on the network, hands it its IP address that it can use. So that, if I set it for obtain IP address automatically, that is for DHCP or dynamic addressing. Give me an address from a DHCP server. So if it's out there, it'll respond, give you the address. I now have this address to temporarily use. Kind of like borrowing bowling shoes if you go to the bowling alley. Same kind of idea. I borrow it for a while, and then I give it back when I'm done. Now, if I set my computer for dynamic and I try to communicate to the network for a DHCP server, I try, and nothing responds, my computer is going to automatically set an IP address. It's automatically going to set a private IP address and a PIP address. It's going to use a number in the range of 169.254 up to 169.254.255.254. Okay, so if I see a number that's 169.254, it's set for dynamic, obtain IP address automatically, and for some reason it has not gotten the address from the DHCP server. Okay. Also remember, when I'm setting IP addresses, if I'm setting here's my IP address itself that identifies this node on the network. The next line, the subnet mask, that tells the device what network it's on. What part of this address up here is network and what part addresses host. In this case, these 3 octets are identifying the network. This last one out here is unique to this host. That's what that's telling that. The gateway, that's the address of a device that will get me off this network to another one or the internet. Typically the address of a router that I'm attached to. It's typically the address of the gateway router that's going to get me out of this network onto another network or out to the internet. Last but not least down here, my DNS. This is the address of a server that will resolve the names I type in, www.formula1.com. It takes that name and translates it into the IP address that I need to look for to be able to communicate with that server, if you will. So this right here is the address of the DNS server that would resolve that name into an IP address. If I want to look at my IP addresses, ipconfig on a Windows machine lets me see the IP. ifconfig on a Linux or Apple machine will let me see the IP address. A subnet is a smaller piece of a network. We are going to do subnetting in this chapter, but just remember the concept. I have a large network. I might break it into pieces for security, traffic control, etc. That smaller piece is a subnet. Here's a quick example to get you thinking. In this network here, I have desktops, IP phones, laptops, or wireless users, if you will. I wouldn't leave this one giant network. I might break this one giant network apart, 172.16.0.0. I might take this network, break it into some pieces. I do that by adjusting my subnet mask. When I do, I now have subnets, smaller pieces, that I can use to assign a piece to the wired users here, a piece to the IP phones, and a different piece to your wireless users. And now, as far as the network's concerned, they're kind of like, I'm using air quotes, are on different networks. They're on different networks at layer 3 because we're subnetting this IP network. This original network here, we've broken into some pieces. We're going to do that later this chapter. Just remember that concept for now. I took a pizza and I divided it into pieces. I took a pie, I divided it into pieces. IP address, again, we have IP4, IP6. Remember 32-bit decimal, 32-bit address for IP4, 4 decimal numbers. IP6, 120-bit address. We have 32 hex digits to represent that IP6 address. My IP version 4 address, which we're going to spend a lot of time with in this chapter. Later in the chapter, we'll do some IP6 stuff. IP4, 32-bit number. Each of those, excuse me, that 32-bit number is broken into 4 pieces, 8 bits each. That's convenient. Each of those 8 bits, if you will, is an octet. And for each octet, I have a decimal number that I use to represent it. That's why we end up with 4 decimal numbers with periods in between. Those decimal numbers range from 0 to 255. 0 to 255. And typically, this is how I see my IP version 4 address. As far as the computer is concerned or the network's concerned, they see the dotted decimal number, or we see the dotted decimal number, and the computers and devices of the network see it as this binary string of numbers. So the decimal numbers are for us humans. The binary is what is really seen by the network cards and the routers and the servers and the devices on the network that are reading and interpret these addresses. Again, remember, ifconfig on Linux or Apple to see the address, ipconfig on Windows to see the address. We should also remember that there are classes of addresses, A, B, C, D, E. Back in the early days of internet, if you wanted to have a device on the internet, you applied to IANA. They would give you a number, an IP address number or class to use, and depending on what you were is the class of address you would have gotten. Okay, we still go over this because kind of like the bones of this are still out there when you're dealing with addressing. The skeleton, if you will, is still out there when we're dealing with addressing. Our Class A network, this was set aside for government use, as in a government of the world. Don't forget there's many governments around the world. So if you were a government and you wanted to get on the internet, you would get a Class A address or a Class A network to use. With a Class A, the first number, the first octet is set by IANA. The remaining 3 octets, the remaining 3 host octets are for you to use how you wanted, that government to use how they wanted. That gave them 16,777,214 addresses to use, because there's 24 bits here, and 2 to the 24 would tell you how many addresses I can make out of those bits. 16 million, blah, blah, blah. Remember, Class A address, the first octet is in the range of 1 to 126. So if I see an address starting at 70. Blah, 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 I know it's a Class A address. Remember your first octet rules. If I were a large business, we're talking like a big Microsoft business or a big Apple or large corporation, okay? A global business, if you will. If you applied to IANA to get an address, you would get a Class B. Class B. Now, a Class B, IANA assigned the first 2 octets. The remaining octets were up to you to use how you wanted. So with that, there are 16 bits here, 2 host octets, 16 bits. 2 to the 16 means you would have 65,534 addresses to use for your network. That's why it was set aside for a large company, large business, if you will. A Class B, the first octet would be in the range of 128 to 191. 128 to 191. So if I saw 150.50. blah, 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 I would know that that is a Class B network. Now, again, remember these first octets. Remember these first octets. Now, if you look at your first octet, you'll notice 126, 128. Oh no, where did 127 go? Well, you should also remember that 127.0.0.1 is your loopback address. So we don't see that listed here as a beginning octet. That is set aside for loopback testing purposes. So do not forget about your 127.0.0.1 as your loopback address. Class C, if I was just a regular Joe Schmo or a small business or even a university, you didn't fit in those other categories, you would have gotten a Class C address, which meant IANA dictated the first 3 octets. The last octet was up to use how you wanted. There's 8 bits there, so 2 to the 8 gives you 254 host addresses that you could use for your network. And with a Class C, the first octet would be in the 192 to 223 range. So if you saw 200.50. blah, 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 that 200 would let you know it's a Class C network. Again, don't forget about your first octet rule and identifying what class of address you're dealing with. There is a Class D and a Class E. Class E was set aside for experimentation, research, if you will. Class D was set aside for multicasting. Class D, the first octet 224 to 239. That network of addresses was set aside for multicasting. Now, unicast is a message that goes to a single node. A broadcast is a message that goes to all nodes on the network. A multicast is to a few nodes. So this might be for a routing protocol. We'll see that in Chapter 9, where it sends out a message to just the routers in the network. Or it could be something like a live stream or a conference. Think about sitting in a lab room. Maybe 2 people in the lab room sign in to watch a video stream, a live video stream of a product release. Well, those data packets coming into the room need to go to 2 computers, not 1, not all, but 2. So a special multicast address would be used to be able to send that same video packet, if you will, to those 2 computers, as opposed to 1 computer or all the computers in the room. So Class D address multicasting gets used for that function. When we come back, we'll continue our review.